Okay, so in this problem, we're going to be working with a paired t-test. So we're going to show you how to do that. Most automobile tires are inflated with compressed air, which consists of about 78% nitrogen. Aircraft tires are filled with pure nitrogen, which is safer than air in case of fire. A study was designed to test whether nitrogen-filled tires would maintain pressure better than air-filled tires. Two new tires were obtained from each of several brand names. One tire in each pair was filled with air and one with nitrogen. So we had this matched pairs experiment. All tires were inflated to a pressure of 30 pounds per square inch and then placed outside for a year. At the end of the year, the pressure in each tire was measured. The amount of pressure lost during the year for the air-filled and nitrogen-filled tires of each brand is shown. All right, so we can see here that we've got a number of tires. Right, we can see here that we've got a number of tires, and overall, the number of tires that we have is 31 pairs. So my sample size is 31 because I have 31 pairs, right? And they measure how much air pressure was lost in the air-filled tires and how much pressure was lost in the nitrogen-filled tires. Now, we want to determine if the data give convincing evidence at the 5% level of significance, right? Alpha equals 0.05, that filling tires with nitrogen instead of air decreases pressure loss, right? So in other words, is it going to be better to fill tires with nitrogen if you are concerned about losing pressure in your tires over time? And is that evidence that we have going to be convincing? Okay. So do the data give convincing evidence? We've got to start with our four-step process, right? So we're going to have our state step, right? Our state step. What are we trying to determine? The state step will include our hypotheses, right? That we have the null hypothesis is that my mean difference is going to be 0. And my alternative hypothesis is that my mean difference is going to be positive, where that mean difference is the true mean difference of air minus nitrogen in pressure loss. Now, this is important that we define our particular variable because, right? Because if I had defined my mean difference is less than 0, then I would be saying, hey, that's going to be nitrogen minus air. And the reason for that is I'm trying to determine if nitrogen lost less air. Well, if nitrogen lost less air pressure, right? If nitrogen lost less pressure, then air lost more pressure, and nitrogen minus air would be negative. But we prefer generally to work with positive numbers, and so that we're saying, hey, that there is a difference in the pressure lost, and we're going to call that difference a positive difference by selecting air filled minus nitrogen filled. Okay, so we want to make sure that we carefully define our items. Okay, then our plan step, right? If our conditions are met, we're going to do a paired t-test for mu sub d, right? Always include what the test is going to be. So we check our conditions, right? What are our conditions? Well, let's see. All right. We know that our treatments were assigned at random to each pair of tires. Hence, the random condition is met. Let's move this up just a touch. This is a well-designed experiment, right? This is a well-designed experiment. So the 10% condition is not needed. We are not sampling without replacement, right? This is an experiment. We don't need the 10% condition for the independence of our random sample. And then we also see the sample size is 31. We have 31 pairs, so our sample size is 31. And because that sample size is at least 30, the normality condition is met by the central limit theorem. So what does that mean for us? What that means for us is that we can proceed with our paired T procedures, right? We can proceed with our paired T procedures now. Awesome. So now we're at our do step. Okay, so what's the do step going to look like, right? So now we are going to be at the do step. Okay, well, the do step, we're trying to test our hypothesis. We know that we have a t-test, and we know that our t-test is going to be the mean difference minus my hypothesized difference, right? So the sample difference minus the hypothesized difference all over the standard deviation of my sample divided by the square root of my sample size, right? So I've got to now try to find these particular values. I've got to try to find these particular values. And we're going to use our calculator to do that. So let me turn on my calculator. So here my calculator is. I've already gone to stat edit and entered in all of the values. I've entered in all of the values, right, from my table. Right, I've got the 7.6 and 7.2, 3.8 and 2.5, right? I've entered in all of those values. Okay. Now, I need to find the difference for each of those. So I'm going to go to list 3 up to the top, and I'm going to say list 1 minus list 2 is going to be input into list 3 because that's going to give me air minus nitrogen, right? That's how I have filled out my data. And so now I have all of those data points listed, right? So I've got each of those differences in there. And now I want to come through and I need to calculate my one variable statistics on those differences, right? So I'm going to go ahead and calculate those one variable statistics, and I can see X bar, and I can see my standard deviation. I can see my sample size. So I'm going to go ahead and write down that information, right? So I'll come back to here to my do step, and my X bar was 1.25 minus my hypothesized is that there is no difference, so minus 0, all over 1.20 divided by the square root of 31. Okay, that's as much as I'm going to do and write by hand. That's as much as I'm going to do and write by hand. Everything else, I'm going to go ahead and let my calculator take care of for me. So I'm going to come back over here to stat, and I'm going to do my hypothesis test. This is a paired t-test, and that means it's a one sample t-test. So I go to my paired t-test, and I can say, yes, let me do it from my statistics. Whoops, let me come back over here. My paired t-test, I can say, let me do it from my statistics, and you'll notice that it's already input my statistics that I calculated. And if I didn't have data, but I knew the statistics, I could input that here. I could also do it from the data list and say, hey, I'm going to do a paired t-test on my data from list 3, right? So I'm going to do a paired t-test on my data from list 3. It is an alternative hypothesis that is greater than, and I'm going to go ahead and come and calculate. And so now I see my particular solution, right? That I have a test statistic, I have a p-value, and I'm going to go ahead and write that information down. All right, so my test statistic was about 5.80. That was my test statistic. And here's what's useful for us. That means for me that my p-value is less than 0.0001. That p-value is going to be less than 0.0001. It's going to be a very small p-value. It's going to be a very, very small p-value when I have a test statistic that is magnitude of 4 or greater. So a very, very small p-value, right? Technically, that p-value was 1.23 times 10 to the negative 6. All right, so a very small p-value. So what does that mean for us? Well, what's going to be our conclusion? Well, this is our standard conclusion for the work that we do. All right, the standard conclusion for the work that we do, we're going to be able to say, hey, you know what? Since that p-value is less than 0.0001 and it's less than that significance level, we reject that null hypothesis. We have convincing evidence that the true mean difference in air pressure, air minus nitrogen, is greater than 0. The evidence is convincing that tires lose pressure when inflated, lose less pressure, right? The evidence is convincing that tires lose less pressure when inflated with nitrogen than when filled with air, on average. All right, that last little piece is important because we're not saying every single pair of tires lost less air when it was filled with nitrogen, or lost less pressure, when it was filled with nitrogen. But we are saying on average, nitrogen-filled tires lose less, right? So remember, when you're doing a paired t-test, you need to go ahead and find each of those differences, right? We need to find each of those differences, right? So that first one will be 0.4. This next one will be 1.3, right? 3.7 minus 1.6, that'd be 2.1, right? But that's going to be a lot of work to try to do, and it's going to end up being better for you to simply use your calculator, right? Simply use your calculator to do that. And once again, on the calculator, stat edit, fill in list 1, fill in list 2, into list 3, type in that it's going to be the difference between your two lists. You get those values, and then you can say stat, right, tests, and run your t-test. Run your t-test with your data, and that'll go ahead and give you the x-bar and the standard deviation that you need, all the information that you need to write down. And you just make sure that in that do step, you write down that information. Okay. Good luck to you as you continue with your work. As always, ask questions where you need.